Hi, linear algebra students. So this is the last video 4, on the makeup classes of invertible matrix theorem. And the only thing we're going to do in this video is a single example applying the theory of invertible matrix transformations. So here goes. Given a transformation from R2 to R2, okay, so we know it's linear and its formula is given with this. And what we want to do is to find the inverse S. The idea is super simple, and that's how you will answer these types of questions. So the idea, find the standard matrix of T, okay, which is A. Let's call this, let's say, step number 1. So find standard matrix of, find the standard matrix of T, right? We will call it A, just for the purpose of labeling it. Then, second step, we will just find the inverse of that matrix. So find the inverse of A. So remember that the inverse of A, we call it A minus 1. And then finally, what we're going to do is we're going to use this inverse to write a formula for the inverse transformation. So use A minus 1 to write a formula for S. Here goes, step number 1. So remember how to find the standard matrix of a linear transformation, and don't forget also that I'm expecting you to show your steps. So you have to compute T of E1. So T of E1 in this case, well, obviously we're gonna have like these two pieces of data. So like two, or actually, well, you know how to do it at this point, but okay, let's just do it to make sure. It's gonna be 2 times 1 plus 5 times 0. And then you're gonna have 1 plus 3 times 0. Okay, so I'm being lousy. You don't have to write this down, but you do have to write that you're finding T of E1 and that the result is 2, 1. You do the same for T of E2, okay, which in this case it's x2 that you replace with 1 and x1 that you replace with 0. Okay, so like 0 plus 3 times 1. And then that's going to give us 5, 3. Which means that the standard matrix of T is the one with these two columns, like 2, 1, 5, 3. As you can see, I'm going slightly faster than in the other videos because you have seen how to do this before. Well, the point is that now that we have A, we will find the inverse. So for the inverse of a 2 by 2, don't break your leg. It's just you're using the formula, right? So 1 over AD minus BC. Then you have like D, negative B, negative C, and A. So we just apply the formula. So again, I'm going to be lousy here. 2 times 3 minus 5 times 1 multiplied by then, so here, that's going to be like 2 and 3, right? Remember that we're swapping these two. So it's going to be 3, 2. And don't forget that for these two, you put a negative sign. So it's going to be negative 5, negative 1. And then it turns out that this gives you 1. So A inverse is simply it. Okay, just because it turns out that the denominator here is 1. So step number 3, very simple. So what we want to do is to find what is S of x. Well, S of x is A inverse times x, because we know that A inverse is the standard matrix of the inverse of T. Okay, so this is by previous theorem, right? By previous theorem. And remember that what the theorem says is that if T is invertible, then the inverse of A is the standard matrix of the inverse of T, right? So just as a recap, if T is invertible, then A inverse is the standard matrix of S, okay? Of the inverse of T, let's put it this way. But keep in mind that this theorem is only valid for linear transformation, okay? And this is important. But in any case, the simple thing that you need to do is to now write the inverse that you found, which is going to be 3, -5, -1, 2. And then instead of x, just write x1, x2. So, doing the calculation, here I'm tempted to, instead of using the row column rule, I'm tempted to use the definition of matrix multiplication. It makes it clearer why you get a given outcome. But that's it. Don't forget, it's the linear combination of the columns of A inverse with the weights x1, x2. So plus x2 times, here we have like -5, 2. All in all, to have the vector 3x1 minus 5x2 and -x1 plus 2x2. So this is basically your final answer. Your final answer is that S of, and actually I'm gonna write it a little bit like further on the left. So S of x1, x2 is going to be equal to the vector with these two components. So 3x1 minus 5x2, and then minus x1 plus, oh, oops, typo here, plus 2x2. All right, this is it. I hope this is helpful, and see you on Wednesday's class. In the meantime, don't forget that this is mandatory and this is also part of your assignment. But you have everything you need for the test. Keep studying. I trust you guys.